This is by far the hardest question in this Olympiad. Great question though. The sum of the factors of 2025 is an odd number. What's the smallest number above 25 for which the sum of the factors is also odd? So you might be tempted to try 2026 and see what happens. 2 times 1013, but immediately stumbling into difficulties because how do we know if that's a prime number or what are the factors of it? If you try 2027, then you know what? That's even worse. What even goes into that? And even if you did manage to get it, we'd still have to deal with 2026 and show that that has an odd or even sum. Um, so that is not going to be the approach. We've got to delve a bit deeper into this problem. And what I did is I thought, all right, let's just focus on 2025 and what is it about 2025 that makes it have an odd sum of factors? So I wrote down its prime factorization. It's going to be 5 times 405. You can kind of use some of the factors up here to help you, or you could just do the division. Then 405 is divisible by 5 as well. And then we're left with 81. Actually, it's 5 squared times 9 squared, or 5 squared times 3 to the 4. Now I decided to work out the number of factors that 2025 has. I mean, I know we can add them up here, but there's another way you can do it without adding up how many there are, and that is to take the powers and add 1 to each of them, and then times them together. So there's 15 factors. So of course, if we've got 15 odd factors and we add them together, we're going to get an odd number. The question is then, how do we get an odd number of factors? And it's something I didn't see straight away, but it comes from the fact that 2025 is actually a square number. So square numbers have an odd number of factors. Because we've got A and B as our factor pairs, and you're going to get, an even number of them normally, but with a square number, like for example 9, you get 3 squared, you get 1, 3, and 9. So you don't get two factors from the 3 times 3. You only get A and A. So square numbers have an odd number of factors. Others have an even number. So the next odd square number is then going to be 47 times 47. Seems quite large, like much larger than the other one. You can work it out. It actually ends up being 2,209, but that is guaranteed to have an odd number of factors. At this point, I didn't quite see what to do. I just thought I'd start playing around with some smaller numbers. So 2, for example, has only 2 factors, 1 plus 2. It also gives us an odd number, so we don't have to have an odd square number, and we've got an even number of factors here, but it's just one that kind of ends up like being the only odd factor. So this would be, no matter how many others you add, like we're going to get an odd number if they're all even. If we looked at 2 squared, we'd have 1 plus 2 plus 4. Okay, it's also odd. 2 to the 3 is 8. So we get 1 plus 8 plus 2 plus 4, also odd. So I just thought, you know what, let's try and get a number that goes beyond 2025, that is a power of 2. And I knew that 2 to the 10 was 1024. That is worth knowing. It comes up in different places. It's related to binary and everything. So, okay, that's too small, but 2 to the 11 is 2048. And that will give me 1, 2, 4, lots of factors up to 2048, but the sum will definitely be odd because this is the only odd factor. So I have a new upper bound. I know that 2048 works. It's just whether there's another one in between 2026 and 2047 that also works. I got to say, I feel like I like stumbled across that a little bit, but I'd like to think that I was, just trying numbers out. And at the end of the day, sometimes solutions come by just trying things out, and then you like later on put the argument together for why it works. I then played around with some powers of 2 times an odd number. For example, 2 cubed times 3, which is 24. We get 1 and 24, get 2 and 12, 3 and 8, 4 and 6. Okay, now I end up with that 3 being an odd number as well, and it kind of wrecks it. This is going to be an even sum. But then what if I try 2 cubed times 3 squared? Well, that's going to be 72. So 1 and 72, 236, 3 and 24, 4 and 18, 6 and 12, 8 and 9. Yeah, I can see there's going to be 4 times 3, 12 factors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got them. So I've got an odd number here. This is what I'm interested in, really, an odd number there. And then one more. So actually this has an odd sum. And now we can generalize, and this is a little bit of a leap, I know, but we've investigated all odd numbers, and we've seen that the only way an odd number has an odd number of factors is if it is a square number. What we haven't done is investigated all even numbers. So we're actually going to do all even numbers in one go. Already found 2 to the 11, so that worked. But what we can do is consider 2 to the n times m, where m is odd. So m could equal 1, in fact, then it would be an even number, but it could be all sorts of different things. Now, all factors of this number are even, except for the factors of m. As soon as you times by a multiple of 2, then you're going to get an even number. So we just have to focus on m. And therefore, we require m to have an odd number of factors. Remember, when we add all the even factors up, we're going to get an even number. But if m has an odd number of factors, then we're going to end up adding an odd number of odd numbers. So we're going to get an odd number. I hope that makes sense. So that means that we require m to be a square number, as we showed at the beginning. Now, if n is even, then we could write like this. The whole thing will be a square number. 2 to the n times m will be square. Because 2 to the n is square, m is square, so the whole thing is square. And so the next one along would be 46 times 46. We've done 45 times 45. I jumped to 47 times 47 earlier on, but I didn't think about what would be 2 squared times 23 squared. And that ends up being 2,116. Now that's greater than the other one I found. So, but that is the next square number along. But we've got one other case to consider. If n is odd, then 2 to the n times m will be 2 times a square number. Because if 2 to the n is not a square number, because when n is odd it won't be, then you can do 2 times 2 to the n minus 1, but then n minus 1 will be an even number, and therefore that 2 to the n minus 1 will be a square number, and 2 to the n minus 1 times m will also be a square number. So, okay, so we're left with that. So let's take our 2025, divide it by 2, and find the square number that's bigger than that. Going to get 1012.5. Well, 30 squared is 900. That's a good one to start with. It's really quick to find. 31 squared is 961. Okay, both of these are less than 1012.5. But if we go with the next one, 32 squared, then actually that is 2 to the 5 to the 10. We're back to our, sorry, 2 to the 5 to the 2. We're back to our 2 to the 10, which is equal to 1024, which is greater than 1012.5. So 2 to the 11 is the, which is, remember, 2048 is the next largest number with an odd number of factors. So quick recap to finish, right? Because here, like, it's all right seeing the solution, but it's like, how would you approach the problem if you saw it again? So, okay, take a look at the next few, 2026, 2027, realize very quickly this is not a viable method. You're going to spend a lot of time finding prime factors, um, trying to get there. Mess about with 2025, learn a little bit about it. What is it that makes that have an odd number? Realized that it's had an odd number of factors, and then that square numbers have an odd number of factors always. We looked at the next odd square number to give an upper bound, so that that's a good starting point. Um, but and to be fair, I could have written down 46 squared there. That would have, that would have also had an odd number of factors. I'm not sure why I didn't do that, but I did it later on. Went back to kind of basics and just investigated even numbers, like not necessarily squares that have an odd number of factors. Start out with the really basic ones, 2, and all powers of 2, in fact. I understood why that worked. Found one that did work that was lower than 2209, 2048. Haven't proved that that is the next lowest yet, but it is at least, showing that like there's a bit more to it than just square numbers. Dealt with all the odd square, all the odd numbers because the next one would be 47 times 47. So now it's a case of looking at all even numbers, a bit trickier, but looked at like powers of 2 times 3 and seen that it is possible to get an odd sum there. Wrote down this general idea, 2 to the n times m, thought about what is it that's going to make that have an odd number of factors. Or the 2 to the, all the factors are even that come from multiplying by 2, so it's all down to m. The factors of m are what are going to be the odd factors. So we require to have an odd number of them. So we require m to be a square number. Looked at 2 different cases. If n is even, then we get a square number. If n is odd, we get 2 times the square number. Looked at the next lowest one in each of these cases, so 2116, which is higher than one we'd already found, showed really where the 2048 came from by dividing 2025 by 2 and then finding the next square number beyond that. And that is a conclusive evidence that this 2048 is the next largest. Wow, what a question. Thanks for watching. Well done.